Welcome back to my channel. We have been discussing on the soil water plant relationship in the last series. In today's lecture, we are going to continue with the infiltration and how to study the infiltration of the soil using different equations. So before getting into what is infiltration, we should understand the after rainfall, you might have seen the water infiltrating into the soil. So what do you mean by infiltration? It is the process where water enters into the soil. This process is very important in hydrology, in agriculture as well as environmental science because it affects the runoff, groundwater recharge and obviously the plant growth. So we can remember the Wayanad incident which happened recently, which is because of a runoff due to high intensity rainfall. So it is vital for ecosystem and effective water management. Infiltration is water flow from surface into the soil. How does this happen? It is guided by two actions. One is the gravitational force, another one is the capillary force. This infiltration process is influenced by different factors like soil type, moisture content, vegetation cover, as well as rainfall intensity. As a thumb rule, we should understand that when the infiltration is high, the runoff is reduced. So in high infiltration, it reduces the runoff as well as the erosion, which preserves the soil as well as the water quality. Moreover, we can also able to prevent the disaster that happens like this Wayanad episode. Now, what are the factors affecting infiltration? First one is soil texture. How does the soil texture influences infiltration? So in the previous video, we studied about the three important components of a soil, that is the sand, silt as well as the clay. And you can remember the triangle that we learned, how it decides the soil type. So sandy soils which is having large pore size, the drainage of the water will be more faster. When if you take the clay soil, the pore size is very less and so the infiltration takes for a long time. The second factor is soil structure. Soil structure in the sense we have to remember the aggregation, how the soil particles are arranged. So aggregated soils enhance the infiltration. If the aggregation is very good, the infiltration will be more. Whereas the compacted soil, it will restrict the flow of water and there is a chance for water logging. Then the moisture content. So you might have seen in your day-to-day experience, if you pour a water to a dry soil, you can see immediately the water will disappear. Why? What happened to the water? Because the dry soil absorbs more water initially until it reaches the saturation point. That is, the dry soil absorbs water more quickly initially than the saturated soils. So once it gets saturated, the absorption will be gradually reduced. Then vegetation cover. So plants have a different pattern of root system with the root hairs and it can able to improve the infiltration as well as the surface protection. That is why if you want to reduce the erosion and runoff, we have to plant more trees. So regions where the deforestation was occurred, you can expect more episodes of this type of disasters. Moreover, in lands with more vegetation cover, the organic residues will also be more over there, which influences the microbial activity. So if the microbial activity is good, the soil structure will be improved in a natural way and the infiltration capacity will be improve. Then rainfall intensity. So here again we can remember the Wayanad incident. So high intensity of rainfall in a short span of time can exceed the capacity of the soil to retain water, thereby causing surface runoff. Now we can move on to the important equations, how to understand this infiltration. First one is Horton's equation. which is developed in the year 1930. He formulated an empirical decay model for infiltration over time. Here he considered time as an important factor. Function of time is equal to Fc plus Fo minus Fc and e power minus kt. What is this Fo? This is the initial infiltration. And what is this Fc? That is the final infiltration. Here we have to remember the constant value, that is K. It is referred to as decay constant. The decay constant is usually a positive value which determines how quickly the infiltration capacity approaches the final value Fc. What are the applications and limitations of this Horton's equation? If you take the application, it is useful for quick infiltration estimate, especially in hydrological modeling studies. What are the advantages? It is simple with readily available data requirements. And what are the limitations? It is not at all based on physical means, and the estimation of parameter is a challenging one, and moreover it is unsuitable for layered or complex soil because it is taking into consideration the important factor, that is time. The second one is Green-Ampt equation. This is based on the physics. So it is a physics-based model. This model considers soil hydraulic properties for infiltration. So what are the properties taken into account here? That is the saturated hydraulic conductivity parameter. So the equation goes on like this. F is equal to Ks into 1 plus xi delta theta divided by F. What is this side? That is the suction head, and Ks is the saturated hydraulic conductivity, and this delta theta is the change in the moisture content, and F is the cumulative fraction, infiltration. So each equation has its own merits as well as demerits. Now let's see what are the advantages of this Green-Ampt equation. This is physically based, whereas the previous one, Horton's, is empirical based. It accounts for soil and water properties. It requires huge data sets pertaining to soil as well as water. So what are the limitations? It also assumes the wetting front. So it requires the soil need to be wetted, and it also requires related soil parameters like the bulk density, pore density, etc. And also it simplifies, it excludes the complex air-water interaction. So this is the major limitations if you go for this Green-Ampt equation. Then the third one is the Phillips equation. This is also a simplified physics-based model which is developed in the year 1950s. So it simplifies infiltration using a series of parameters, and the equation goes on like this. For T is equal to 0.5 into S into T power minus 0.5 plus A, where S is the sorptivity, that is the capillary forces. Remember, as I told you in the first slide, the infiltration is guided by two major forces, that is gravitational force as well as the capillary force. Here in this equation, Phillips equation, it considers the capillary forces, that is sorptivity, and A is the constant which is related to conductivity. So what are the uses of Phillips equation? It is ideal for short times and for uniform soil condition. We should not forget this. So if you want for a short time period, you can use this Phillips equation. And if the soil condition is also uniform, you see it is having a saturated zone, then followed by an unsaturated zone, then the bedrock. If the condition is similar and above it is the surface water. So it is, if the condition is uniform, you can apply this Phillips equation. What are the uses and drawbacks of this equation? It is simple alternative to Green-Ampt model, and it is also good for the initial infiltration studies. As I explained, it is suitable for short infiltration events. If the rainfall is there for 1 hour, a short span of time, or 30 minutes or 1 hour, if you want to study how much water get infiltrated, you can very well use this Phillips equation. It is less accurate for long duration. If there is a rainfall for overnight, maybe it's for 12 hours continuously, this equation doesn't work. So, and it assumes uniform soil, as I showed you the structure of the soil in the previous slide. However, this is limited for complex soil profiles. So far, we have discussed about what is infiltration. We understood the concepts and factors influencing infiltration, and we learned about three equations. One is the Horton's, Green-Ampt, as well as the Phillips equation. Horton's is an empirical model. It is very simple and it is required for site-specific parameters. Whereas Green-Ampt is physics-based, it requires all the data of the soil as well as the plant. So it requires a large data set. Then Phillips, it is again simplified. It is best for short-term estimate. It is not applicable for long-term studies. It is only for short-time estimation of infiltration. So based on the data availability and accuracy needs and based on the purpose or research need, you can choose any one of these equations to calculate the infiltration rate. So nowadays, we are having sophisticated facilities like remote sensing and geographic information system and big data analytics and AI models for improved modeling of these infiltration studies. So if you want to pursue research and if you want to study infiltration and if you want to contribute how to reduce the runoff after this rainfall and to protect a community, you can very well pursue your research in these recent cutting edge technologies like remote sensing, GIS, as well as AI models. Thank you.